people flow, because it's really important for us to improve the user experience of our student and staff. So we created this platform to enhance, as I mentioned, the management of the information, and we created this asset information system operable by web app. And we work on reducing risk, time and cost of planning. We are renovating our buildings. There is a project of the university that is called Reinventing UNITO. UNITO is University of Turin, so we are changing the destination of our buildings and in the cities to optimize the people flow and the activities of the offices and so on. So we created this digital twin. In this moment, we have some pilots buildings where we are collecting data from the classrooms about the indoor condition, for example, temperature, humidity, CO2 concentration, VOC, and so on. And we are extending the information about the people flow, the real occupancy, because we know that if we want to optimize, for example, also the HVAC system functioning, we need to know the correct number of people inside the spaces and the lightings and so on. So we wanted to exploit our digital twin for the preventive and guided maintenance and the real-time performance adaptation of our buildings and spaces, and to optimize different activities inside the building, and moreover the real-time fault detection and emergency alerts, because we are also considering the security and safety of our users into these buildings, that they are not always compliant with the regulation about energy for sure, but also in some cases of fire protection. So we are increasing the safety and security of our buildings. As I mentioned, we have a lot of square meters to handle. So these 120 buildings, and this here you can see the different courses that we have, a number of administrative teaching staff and students. And it's a very complex system to handle. So we created this integrated database and the asset management system app that are used to unify the databases of the different directorate, because, for example, we have a directorate for education that has the data about number of students and courses and the classrooms, or the safety and logistic maintenance directorate that is controlling all the activities of maintenance and the spaces, the sustainability and building directorate, and so on. And every directorate is managing their own information. So going ahead, we worked on the safety, the fire emergency management. So we started to organizing our simulation on a pilot building that is a big building hosting the humanities faculty, that hosts the 25% of all the students of the University of Turin. And we performed the crowd simulation scenarios to understanding if it's we are renovating the building, and the national Italian regulation is only about some specific parameters about the people density and the time for evacuating the people in case of fire emergency. But we want to be sure about the real possibility of the crowds to go out of the building. So we performed a dynamic simulation. We used, here you can see the case study, the Palazzo Nuovo, where we have 5 departments and 7,000 square meter and 23,000 students, and plus all the staff members. So we performed 2 different levels of simulation. Here you can see the parameters about the risk. We have the density, the 5 people per square meter. And we created this agent for the user speed with the probabilistic distribution of their movement. And then we wanted to check the efficiency, but also the limitation of the prescriptive approaches in the fire regulation in Italy. And so we wanted to identify the data that we need to include in our platform for checking this purpose. Here you can see the simulation scenarios about the section of the building, and in a specific case where we have the fire in front of the staircase, so people are not allowed to use all the possible staircase of the building. In this case, we could see that we have some problem, because also if on the paper the building is compliant with the regulation, in case of a specific hazards and with the dynamic simulation, we demonstrate that we have a time of escape that is higher and greater than what we need for to be compliant with the regulation, and so we have a very negative impact and in the hazardous event. For that reason, we want to use our digital twin also for having the correct number of people inside the spaces with the real-time people counting, for having the possibility to create different scenarios and use the machine learning to support the different escape we're finding during the events. Here you can see a specific dashboard that we created in our asset management system for this fire emergency management, where we have the parameters that we need for calculating the time of escape for the national regulation, that is 1 minute, and the real time that we need with the dynamic simulation, that is 12 minutes. And so the percentage, or an idea of the situation, the emergency situation in the red display that you can see on the right side. And so, yeah, okay. So in our idea, yes, we are using this digital twin also for that reason. We are supporting our simulation with data also that we want to collect with rovers and drones that we have at the University of Turin, about to map all the openings, the updated system that we have for fire purposes, and other also for comfort condition and facility purpose. So we will investigate the use of AI and virtual reality to enable cognitive feature for this fire emergency. And I thank you for the attention. Here you can see an image of our platform. If you have any question or do you want to cooperate with us, here you have my email and the mail of the group. Thank you so much.
Lavinia, are you using PyroSim or Pathfinder or
yes,
which
also,
these softwares?
Yes.
Okay. Thank you very much. So now it's time for intelligence platform. So Sven-Erik Schapke from LogLab from Germany. Right?
Yes. Yep. So thank you. I hope you hear me well. So my name is Sven-Erik Schapke. I've been into the BIM and digital twin area for around about 20 years now. I just recognized quite a lot of years. I've been also active in research and standardization. But today I'd like to talk about LogLab, which I have just recently joined the company, and thanks Eduard for inviting us to. It's actually more a business case than an industry case. And it's a little bit about our company and the way of our company. So what is LogLab doing? LogLab is actually building digital twins since 2017. Obviously some digital representation of real world objects. In our cases, this is 80% existing buildings. So there are no BIM models, sometimes they're not even drawings. We do digitize existing structures. But when we do that, you've seen that it's object-oriented. So it's not a facade, it's not just good looking, it's actually semantic objects. They all have an address, and you can connect it to other systems. But what you also see, these models quite often are quite a bit of fun. And that's an important part of our job. We have, over the last years, built more than 4,000 models and used them in various digital twin use cases, from training, asset management, documentation, etc., etc. But essentially, we always started to scan the environment or maybe take some drawings and design information. And then we did a lot of custom development and development with software partners. And one of the problems is we had a lot of customers saying, this is great, but I need an update from these 4 models and then these 20 models. And we recognized this is not scalable. They wanted to use more standard applications, not custom applications. They wanted to have more models faster. So our result was, okay, we need another partner. And so the company has been acquired by Hexagon last year, which is a large company. And for us, that was clear. We need to port our technology, which we all called platform in the beginning, but it was our platform, to a platform that we share with a lot of others. So essentially what we did, say, we have 3 topics. We need to scale how we build these models, so scanning, collaboration, changing, updating, maintaining. We need to scale the way and be more flexible how we connect with other systems. So we need bridges, smart connectors. And obviously, I mean, the industry, generative AI is on everybody's door. People expect these models to be generated a lot faster. We've always been using intelligent, smart services, but obviously we're also investigating a lot of that new technology. So this is the topic. And fortunately, some of the stuff we do there are on this Hexagon digital reality cloud that we're using. Some of that technology we already have and put it on that platform. And some of them, that technology we find with partners, and particularly partners that have larger platforms as well. Not like single partners, we still work with them, but the idea is really scaling with open, established platforms. So what is our platform? Hexagon Digital Reality is a classical platform with user management collaboration. The special things is it has a lot of visualization technology and quite a lot of automated services that we can use. And here are some of the apps you find on there. So global geospatial data is on there. Scanning, a lot of the Hexagon Leica scanners are connected to that. All that stuff is available. And how we use it, we essentially use that platform to support this workflow from the first capture of the data to spit out a model or a full application in the end. And obviously in 10 minutes, impossible to give you an insight on each of these steps. So I'm just picking a few. That is exactly the beginning where we use a lot of Hexagon technology. Scanning technology, automatic meshing, automatic registration. All this, I think we've had that in one of the workshops. Whatever scanning technology or sensor you're using, you're integrating a lot of data, and you need to clean it up and harmonize it and simplify it, essentially. Then obviously we're using a lot of machine learning to actually generate models, but that's a whole lecture. So one of the things I wanted to point out is with the new technology, things are converging. We're not talking about large-scale model, small-scale model, point clouds, models, or semantic models. This is all coming together, and we see that very nice. This is a model from Munich, aerial LiDAR scanner, very much on top. The whole Munich area then merged with scanning data from the street. And then if you go a bit further, this is obviously where we want to go. Same model, but then integrated and overlaid, or you can just feel it with a loglet model, which then is really object-oriented model that you can further process and further integrate. So here, worlds are coming together. One step further in that chain, it's a little stuck. how do we provision these models? Quite often we used to ship these models. Now obviously we have them on an open platform, and essentially there are 3 ways our customers get these models. One is typical BIM or CAD formats, and then we support a handful of them. Not all of them, but quite a few of them. Then obviously we have our own viewing technology that works both on the client as well as on the web. So we provide you a viewer to look at all our models, and you see that is a quite nice immersive feeling. It has a lot of key core collaboration features. But what we also do is we ship that into mixed reality or virtual reality environments. And then you can take it from there. And the key point I'm making here, virtual or mixed reality platforms, this is a whole universe of software that's out there. Don't try to reinvent it, but hand over the data. Then obviously we're working on quite a lot of tools to make integration easier. That is low-code connection to IoT or asset management, filter data, write rules to map data, etc., etc. Our own viewer, obviously, you can integrate as there's an SDK available. And then last but not least, we do custom development with some of our tools. So summarizing up, these are the use cases we have across the life cycle of a building where we use our twin. So getting the data, using it in design, using it in documentation, using it in training, using it in operations. And there are quite a few platforms out there where we're trying to make that connection and not do the technology ourselves. Yes, it's a bit of name dropping. There are quite a few new partners, but this could be smaller partners as well. We don't mind. The most important is it is established, it's there, and it's scaling. Otherwise, we don't get the speed that we want. And then obviously leaving you with, so like a video that goes through the whole chain from the beginning to the end. That's quite a bit of hexagon technology. And at the end, it's Omniverse that consumes it. That is the digital reality platform. We go in, that is the geospatial information that's already available. We're looking at one factory from Hexagon in Switzerland. You see a little bit how we went and scanned the facility just with a small mobile scanner. The data that automatically comes from that scanner, you see it's sparse, it doesn't look that well. And then obviously the model that we created with the LogLab technology, cleaned, object-oriented. Then you can tear it apart, you see that. And then what we did with that model in this case, we handed that over into the Omniverse, and then the Hexagon robotics department were using the models to actually run their robots and do all their autonomous simulations. So we essentially in the end, we are just the space for the robots to interact in. That is like our story. And I can pause.
Thank you very much, Sven. And now we will connect via streaming with Simone Robert and Massimo Penasa from KMATE, and they will be talking about simulation-based digital twin for monitoring and predictive maintenance. So let's pray that everything goes well. Okay.
Hi, everyone. Can you hear me?
Yes.
Okay. So thank you very much for this opportunity. For us, it's a pleasure to be here talking to you about our solution. Let me share the screen. So before talking about our innovative solution for the monitoring and predictive maintenance of infrastructure, let me first introduce ourselves. We are an IT engineering company based in Bolzano, northeast of Italy, that developed with Statics SHM, a platform realized for the monitoring and predictive maintenance. We are a team highly qualified in the field of IT development, numerical simulation, BIM, data sciences, and artificial intelligence. But why we are focusing on this subject, the monitoring and predictive maintenance of infrastructure? Well, the problem is that we are facing a really big challenge. All our infrastructure are aged, they are old, and there is the need of a solution that could reliably establish if the asset is safety or not, and through predictive maintenance could extend the useful life of the asset. Unfortunately, the current monitoring approach do not allow this, because nowadays what we see is that many sensors are applied on the bridges, for example, that we want to monitor, but they collect many data, but the data at the end are only numbers. They do not answer an asset owner's question: is the structure safe or not? This reason, we develop an innovative digital twin. Innovative because it automatically and continuously updates itself based on the data coming from all type of sensor installed in situ on the structure. And it's a new approach because this digital twin is based on numerical simulation that provide the customer the real state of and the stresses to which the structure is subject. And through our physics-informed artificial intelligence, we are able to even predict the future behavior of the structure. What does Statics SHM do? First of all, it allows the customer to conduct 3D inspections from any devices that could connect to the internet. It allows the continuous simulation of the continuous numerical simulation, and hence the assessment of the entire structural state. And as I said, through advanced algorithms of artificial intelligence, it can predict the future behavior of the structure. But why does it work? It works because it looks at the meaning of the data. It not simply collect data coming from the site, the structure. It can interpret this data looking at what is really happening to the structure. In fact, returning the real stresses to which the structure is subjected, we can assess if and how the structure is safe and where we should go with maintenance. So we are able to focusing our actions. And again, with artificial intelligence, with Statics builds a self-learning system that can predict the future and becomes better over time. For time reason, I will just focus on one case study, but there will be many more. Let me recall this example. This was a case study related to the Austria Autobahn. An important bridge had to be demolished much before the predict lifespan that was designed. For this reason, the new structure, the asset owner wanted for the new structure a reliable system that could assess the safety of the structure and could optimize maintenance. So, through our system, we had realized the digital twin that was fed by data collected by a distributed fiber optic sensor. Our system is able, because the system is currently working, is able to assess the safety factor that is an essential parameter for an asset owner, and could automatically evaluate the eventually damage that could occur to the structure. But the reason why I report this case history is because we obtain a strong validation here. In fact, the asset owner asked us to predict what will be the deformation that will occur after a loading test they made. And the system was able to exactly predict the deformation that occurred in real life. And this is quite sensational if we consider that the structure turned to be 33% more stiffer than the design value. So our system discovered that a strong discrepancy between the design and the built structure. And this is not always good to be stiffer, even especially in a seismic area like this. So I hope I could highlight the point of our solution, but for sure, if you have any question or curiosity, please reach us by mail. Thank you very much.
Thank you very much, Simone and Massimo. So let's go for the last presentation of this first session, and it's time for Natalia Oliveira from ESE and NIMA, and she will present the international perspective of digital twins and data challenge.
Thank you. Hi, everyone. Well, my name is Natalia. I am an architect. I have a master's degree, and I am partner and director of Studio ESE. It's a BIM office in Latin America, the first one certified in ISO 9001. And we work under the standards of ISO 19650. So, but here today, I am representing Women in BIM. I am also mentor lead. I am also in charge of the mentor program scheme. And also I am here on behalf of NIMA. I am representing NIMA today, which is NIMA. It's ex-UK BIM Alliance. So it's a non-profit organization that promotes information management best practices, helping to support digital information across build, and manage environment. So today I want to give you a few inputs about how important is the information and the quality of data that we are using in our digital twins, and everything amazing that you are guys developing and showing today. So our mission at NEMA is to inspire, influence, connect, and support everyone active in transform, build, and manage environment. So this is why I'm here. And we believe that with trusted data, great thing happens. So as we see. Well, digital twin, it's important, the quality of data, making sure that everything is top-notch. It's not about having the right data, as you say. It's also about knowing how to handle it properly. So I will walk you through the challenges that we are facing, keeping our data deep-notch, and also talk about the rules, some rules and guidelines that we're using in UK, also Latin America, about to gather and organize all this information. The thing is, like, digital twins are demanding all around the world. The demand is rapidly increasing. So this is raising data challenges that need to be urgently addressed for organization if they are going to fully trust benefit from their digital twin. So as the example that we saw a few minutes ago, so it's really exciting. So the current situation is not like an ideal. So I am talking more about in the practice what I see every day when I walk through a client, or when a client wants some information and then everybody delivers something different because they don't know what format to follow. They don't know how to submit the information. There's something that needs to be cross everything. So digital twin, of course, is a potential, and it's obvious that it's going to be it's the future, but the effectiveness of the digital twins rely on the quality of the data and the accuracy in the time that we are receiving this. So with this phrase that we use at NEMA, with trusted data, great thing happens. To be able to accomplish everything, we need to establish some basis to everyone agree on how to manage the data, address the challenges. Industry stakeholders must prioritize data governance, ensuring that the data is collected, managed, and shared in a standardized and transparent manner. So I'm going to skip this. So how we can organize everything, we need to work with global standards. So in a digital twin, we receive information from different ways, from sensors to BIM. We gather that information from, there's plenty of ways that we can gather that information, but we need to follow something at least. So ISO 19650, it's a standard way that it's international standards, that defines a common unified framework for effective collaborative production and management of information across the full life cycle of an asset. So the information management requires three overlapping components, equally important: people, process, and technology. And we always focus about more technology than people, and that is, I want to bring that awareness. So how the ISO 19650 is going to help us? Well, basically, there are three areas that this standard stands for, that are the data standards, data validation, and information management. So about the information management, this includes like the requirements, ensure that what we are going to deliver, it's what the client needs. But and me, as when I receive the information, I need to be clear what I want. So these standards, if you follow them, there's specifically their focus on asking those requirements. Also, the standards, there's a specific guidelines for standardization and classification of data within BRIM processes in this case. So naming conventions on the state of the information, that is also something that we struggle with. If that is the information that is updated, if it's not updated, where it's going to be located. So this is one of the best thing that this standard propose, how to manage the state of each of the information. So if it's achieved, if it's published, if it's shared, or who is going to be in charge of. So and last but not least, I mean, I can talk about hours about this, but data validation. We need to invest time in validating the data. We need to invest time in knowing who is going to be in charge of reviewing everything. Because even though we can rely on some routines, we use Python and stuff to populate the information in our MIM models, there's sometimes that criteria that only humans have. So we need to take risks, but not that much, because the information needs to be accurate. So, what? Okay. So also I want to talk about the National Digital Twin Program that it's going in the UK. That it's the aim is to promote an ecosystem of connected digital twins for foster better outcomes from our built environment. So since 2018, the National Digital Twin Program have been functioning to help organizations understand digital twins and support them integrating the model into their operation. So the primary goal of this program is drive innovation, improve efficiency, and enhance decision-making across the life cycle of an infrastructure. So one of the most programs that they have is the Gemini principle. So I'm not going to, I would like you to get more information, but for me, the most important are, those are guidelines of what a digital model, a digital twin should have. For me, the most important are like security, must enable security and be secure itself. Openness, must be as open as possible. We are working with a lot of different programs and data, and it must be as open as possible. And quality, it must be built on data of an appropriate quality. So, and the last two for me that are more important, it must have a clear ownership, governance and regulation. This is vital because we are having issues on where it's going to be hosted, how is the data, how is my data is going to protect, who is going to own, because it's going to be hosted on the digital twin platform or in mine. How can I? Those are my data. So. And last is evolution, must be able to adapt as technology and society evolve, because this is going to be beyond us. This needs to be useful in the future. So we need to think about this. For these Gemini principles, I think those are really, really important. So, well, just to closure, the despite these challenges, well, the potential benefits of digital twins are too significant to ignore. So this is the way. By addressing the data quality, I believe, and we believe, and fostering collaboration among stakeholders, the industry can unlock a full potential of digital twins to drive efficiency, innovations, and sustainable growth. Thank you.
Thank you very much, Natalia. And now, well, we have to close the first session. We have learned about, with 10 very nice presentations about if human was in the loop or on the loop, about BIM to life cycle assessment, about how to compare what is built and what is planned, to be safer with artificial intelligence, how to make 20 million homes, or how to begin a blockchain startup, or how to have a escaping twin, or things like this software, We Statics, the Omniverse, and Woman in BIM or Woman in Digital Twin. So we will skip the round table. We will have a coffee. You know that someone has said it's obvious it's the future, but is it the present? After the coffee, there will be the answers. See you in 10 minutes. Thank you very much. To go upstairs. Okay.
This feature empowers city planners, architects, engineers, and policymakers to comprehensively visualize and analyze various aspects of urban environments while ensuring compliance with relevant regulations.
Que temo és que si arrenca per lo que sigui i vosaltres no heu acabat el so.
No, no.
At Intelligent Network Solutions, we've developed Nexus Twin, an all-in-one digital twin platform crafted for urban planners, cities, municipalities, and policymakers to digitally transform and streamline their built environment processes by transforming their data into CIM City Information Model. Nexus Twin is more than a mere tool, it's an essential partner in your digital transformation journey. This platform melds the detailed mapping capabilities of geodata with the structural insights from the OpenBAM models, crafting an interoperable and interactive digital twin that spans the lifecycle of construction projects, from design through construction to maintenance. With Nexus Twin, users can visualize complex data layers, facilitating data-proven decision-making for urban landscapes. Being a web-based platform, Nexus Twin enables users to access data from various sources such as CAD drawings, building models, infrastructure models, sensor data, point cloud, and other third-party sources. The digital twin framework of Nexus Twin not only provides users with essential data insights for effectively managing large-scale projects in urban development, but can also automatically cross-check the OpenBAM and DWG data against local regulations. This feature empowers city planners, architects, engineers, and policymakers to comprehensively visualize and analyze various aspects of urban environments while ensuring compliance with relevant regulations. At Intelligent Network Solutions, we've developed Nexus Twin, an all-in-one digital twin platform crafted for urban planners, cities, municipalities, and policymakers to digitally transform and streamline their built environment processes by transforming their data into CIM City Information Model. Nexus Twin is more than a mere tool, it's an essential partner in your digital transformation journey. This platform melds the detailed mapping capabilities of geodata with the structural insights from the OpenBAM models, crafting an interoperable and interactive digital twin that spans the lifecycle of construction projects, from design through construction to maintenance. With Nexus Twin, users can visualize complex data layers, facilitating data-proven decision-making for urban landscapes. Being a web-based platform, Nexus Twin enables users to access data from various sources such as CAD drawings, building models, infrastructure models, sensor data, point cloud, and other third-party sources. The digital twin framework of Nexus Twin not only provides users with essential data insights for effectively managing large-scale projects in urban development, but can also automatically cross-check the OpenBAM and DWG data against local regulations. This feature empowers city planners, architects, engineers, and policymakers to comprehensively visualize and analyze various aspects of urban environments while ensuring compliance with relevant regulations. At Intelligent Network Solutions, we've developed Nexus Twin, an all-in-one digital twin platform crafted for urban planners, cities, municipalities, and policymakers to digitally transform and streamline their built environment processes by transforming their data into CIM City Information Model. Nexus Twin is more than a mere tool, it's an essential partner in your digital transformation journey. This platform melds the detailed mapping capabilities of geodata with the structural insights from the OpenBAM models, crafting an interoperable and interactive digital twin that spans the lifecycle of construction projects, from design through construction to maintenance. With Nexus Twin, users can visualize complex data layers, facilitating data-proven decision-making for urban landscapes. Being a web-based platform, Nexus Twin enables users to access data from various sources such as CAD drawings, building models, infrastructure models, sensor data, point cloud, and other third-party sources. The digital twin framework of Nexus Twin not only provides users with essential data insights for effectively managing large-scale projects in urban development, but can also automatically cross-check the OpenBAM and DWG data against local regulations. This feature empowers city planners, architects, engineers, and policymakers to comprehensively visualize and analyze various aspects of urban environments while ensuring compliance with relevant regulations.
Pataca.
¿Habla? ¿Hola?
Hola. Sí, sí.
At Intelligent Network Solutions, we've developed Nexus Twin, an all-in-one digital twin platform crafted for urban planners, cities, municipalities, and policymakers to digitally transform and streamline their built environment processes by transforming their data into CIM City Information Model. Nexus Twin is more than a mere tool, it's an essential partner in your digital transformation journey. This platform melds the detailed mapping capabilities of geodata with the structural insights from the OpenBAM models, crafting an interoperable and interactive digital twin that spans the lifecycle of construction projects, from design through construction to maintenance. With Nexus Twin, users can visualize complex data layers, facilitating data-proven decision-making for urban landscapes. Being a web-based platform, Nexus Twin enables users to access data from various sources such as CAD drawings, building models, infrastructure models, sensor data, point cloud, and other third-party sources. The digital twin framework of Nexus Twin not only provides users with essential data insights for effectively managing large-scale projects in urban development, but can also automatically cross-check the OpenBAM and DWG data against local regulations. This feature empowers city planners, architects, engineers, and policymakers to comprehensively visualize and analyze various aspects of urban environments while ensuring compliance with relevant regulations.
the most environmentally damaging
At Intelligent Network Solutions, we've developed Nexus Twin, an all-in-one digital twin platform crafted for urban planners, cities, municipalities, and policymakers to digitally transform and streamline their built environment processes by transforming their data into CIM City Information Model. Nexus Twin is more than a mere tool, it's an essential partner in your digital transformation journey. This platform melds the detailed mapping capabilities of geodata with the structural insights from the OpenBAM models, crafting an interoperable and interactive digital twin that spans the lifecycle of construction projects, from design through construction to maintenance. With Nexus Twin, users can visualize complex data layers, facilitating data-proven decision-making for urban landscapes. Being a web-based platform, Nexus Twin enables users to access data from various sources such as CAD drawings, building models, infrastructure models, sensor data, point cloud, and other third-party sources. The digital twin framework of Nexus Twin not only provides users with essential data insights for effectively managing large-scale projects in urban development, but can also automatically cross-check the OpenBAM and DWG data against local regulations. This feature empowers city planners, architects, engineers, and policymakers to comprehensively visualize and analyze various aspects of urban environments while ensuring compliance with relevant regulations.
Perfecto.
At Intelligent Network Solutions, we've developed Nexus Twin, an all-in-one digital twin platform crafted for urban planners, cities, municipalities, and policymakers to digitally transform and streamline their built environment processes by transforming their data into CIM City Information Model.
Okay, welcome back, everyone, from the coffee break. We will now start the second part of the Congress, and we will start with our first keynote speaker, Christoph Strunald, is the Deputy CTO for Technology Innovations in Software AG, and he will talk about the distributed digital twin architecture. Thank you, Christoph.
One, two, three. Yeah, thanks a lot for the nice introduction. My name is Christoph Strunadl. I'm the Deputy CTO of Software AG, and you might rightfully wonder what I do in my daily life, not holding presentations. That's actually very simple. I'm taking advanced concepts like GaiaX, no one really knows. I mean, a few would know. They are here in the technology readiness level 0, 1, 2, 3. And then I observe them, identify Software AG is an integration company. So we have products like an IoT platform, like API gateways and all that used to connect things and IoT systems and construction sites. Identify how to use GaiaX technology in our products and then sell it to our customers. Potentially guys like you, ladies like you, using it in a construction site. And the thing where I have actually do a massive coming out today is I have no idea about building, about construction, about BIM models, about the eco sector. I learned that. So this is a true example of a hopefully successful interdisciplinary work in a project, in the iEco project, Intelligent Empowerment of the Construction Industry. Why did we choose a construction project for? Why shouldn't we have manufacturing? And the idea is we're an integration company. The construction business is not a point-to-point business. The whole ecosystem is not a point-to-point system. It's what we today, using GaiaX technology, would call an ecosystem. And the things we wanted to explore is, can we implement something interesting, useful, moving forward the whole sector using GaiaX, that is ecosystem principles on the technology side. And the project is quite interesting because it starts right from the beginning of any construction process, like with the planning, includes all the, how many professions are typically involved in a construction project, including operations later on, I don't know, 60, 70, 80. And the idea is to use a select couple of use cases, we call them advanced smart services, and use those use cases to test ecosystem principles. Now, what is an ecosystem principle? I have one of the use cases we do starts in planning, obviously. This is a natural progression. What is a planning in the environment use case? It could be BIM and GIS taking together. We have seen that actually. So you have two parties, but this was not enough for us because two-point peer-to-peer interactions you could use using, I don't know, any file transfer program. You know, FTP, vTransfer, move everything into your CDE, your common data environment, if you happen to trust the Adobe Construction Cloud, or simply send email, and it works. What we try to come up with use cases where you use 3 parties or more. And the key question for that one is who would be the third party or the fourth party? And I leave that to you. I have one example later on in this slide. A key element of the use cases in IECO is that every single use case has its own solitary, isolated business case. So if you use those principles and you just implement that service, it will already have a positive payback, a positive return on investment. The key idea of the ecosystem approach is that if you want to include all of the different participants, and 80% of the participants, the professionals, have fewer than 5 or 6 people in their companies, how would you do that? And you can only do that in a uniform manner, a flat access mechanism. And how would it look like? I'm going to present later on, very technically. But every single use case has its own return on investment. Of course, if we later go to the construction site, we are using IoT. For instance, that's a very nice use case where we have employed drones, which are flying outside the building, identifying windows which have been put into the hopefully correct position, mounted there or not with a barcode, etc. And then this intelligent drone and back office would automatically kind of log the performance of whoever mounted the windows and then send an automatic invoice. So you can see a lot of parties involved, and you can see also the efficiency. Normally someone would have to do the failure report and go around the building and photograph everything. And of course the speed, which is attractive for all the parties if you get money earlier. And later on, of course asset tracking, we had that early on. And later on, very important, because that's of course the facility management and operations phase is the longest phase in the building life cycle at all. And this potentially would be also a consumer of the early phases of the document. Because those guys, the CAFM, the computer-aided facility management developers and guys, they would need the data from earlier phases if they want to, I don't know, change the building, look what has been built, what has been planned. Of course, you do a little bit of AI here as well. Interestingly, if you have data produced and available in the very early phases, and you know someone who has a business benefit from using that data, there is an idea that you could sell your data or access to the data to downstream operators, to downstream facility managers, and this is the high goal of data monetization. But in order to be able to do so, we need to have kind of an access mechanism how to do that. And what actually the task we set out to solve was to build a digital twin or an architecture for a digital twin incorporating all the professions, all the data, so it's much larger than a digital building twin, including the construction site, including the checking, including later facility management, so potentially everything. Actually, everything plus data sharing in a sovereign manner. Because data sharing in a sovereign manner means if participant A planner, wants to share the data, that planner, participant A, needs to retain all the rights, the access and usage right, how and when, and especially with whom to share that data. If you think about the dozens of different players, actors, there are many different professions and data types, how the hell would we be able to come up with a generic way to kind of orchestrate, formulate, define those digital twins? And there we turned to the ICDD standard, which is the information container for linked document delivery. And we generalized that. The idea is to have just a DTW link model capturing the relationships of your digital twin. So all the actual data is stored here and here, but the link model is capturing much better than typical digital twin definition languages. It's capturing how those different data sets are linked. There are many asset administration shells, many digital twin languages. They all suffer from a common problem, an ontological problem, that they only know triples. So the relations are limited to binary relation. That's very cumbersome to model in relations involving 3 or 4 or 5 or 10 things. So this link model standard, the ISO 21597, incorporates that. Of course, you need a little bit of repository admin. I noticed that the digital twin DTW is kind of the British way of abbreviating that. That was just per accident, that we did not need to have DDT, the poison, as an abbreviation. So how then would anyone access the digital twin? And as always in an architecture, you invent components. So you have a participant, and the participant would have, and we have called it resolver, a software, and magically, or via standards, actually via GaiaX standards, that resolver would take the link model and go down to each of the data sources, and then can be 1, 2, 2,000, doesn't care, and fetch the data and do something sensible with the data. Unfortunately, I have to dispel a common myth in data sharing. If you share the data, it's gone. There's no way, if you have shared, I don't know, the IoT data of a device for the last 24 hours, it's gone. No data space protocol is able to solve that. So you need to be careful whom to convey, whom to send the data to. But this is an unsolvable problem by principle. If you look at that model, many of you will understand that, but you would immediately tell me, Christoph, this is a greenfield approach. We don't start at zero. We have already many systems here, Revit, whatever model checker you have. How then would you access the digital twin model? Of course, architecture pattern number 2 here in this slide, you would need some adapters, and those adapters would do the translation work back and forth to your Revit, to your system which you have in-house. My wild futurist expectation and hope is that once the standard has gained traction, that all the construction business software vendors would implement kind of the GaiaX standards, so that you don't need any adapter or whatever, that everything is already a full-fledged resolver. Where does GaiaX, so the European cloud infrastructure services ecosystem, where does that come into play? And there is an easy and a more difficult and more contrived answer. The first one is someone needs in the ecosystem to take care about which digital twins are available. We do not think that there will be a single digital twin under the governance of a single participant. Not gonna happen. So we will have you need a catalog listing all the potential digital twins, all the different, in form of the link models, and all the different data sets which are linked by those models. And this catalog feature, by the way, would also allow someone else to maybe construct a second or a third digital twin using your data set, maybe against a small fee, usage fee or whatever. Of course, you can also specify the standard allows that some ontologies natively in order to make dynamic processing, automated processing work a little bit better. The second, even more important input from GaiaX to that is sovereignty. As I explained earlier, sovereignty means that those participants decide whether they want to share data or not. And in all the GAIA-X architectures I know, these components are neglected. We have published that. Actually, you can read that on our web page. Organization always have something like an API gateway, a firewall for application requests. If you reformulate that in terms of policies, it's the so-called policy execution point. In that point, someone is calculating the rules, the access and usage rules. This is a policy and you have some context and there is a decision, and this one says yes to the incoming request or no. This is the point where your data sovereignty is actually located. If you're a very small company, you would not install that all on your system, on your premise. If you're an electrician with 3 people and have a server and an API gateway, you would go in your sovereign decision. You would go to your favorite cloud provider for that and use them. And if you are not happy with that cloud provider, you can change to another one. Your decision, your data. This is the way where, this is the point in the architecture where this control is executed. And of course, the other one also has a policy as well. I see someone taking notes. If you direct message me, you can get a copy of the slides. There is actually a paper, and I'll tell you later on, which you can claim from me as well. The only problem, and this is currently not solved by GAIA-X standards alone, is this policy execution kind of relies on 2 input variables only. One is the one who is sending the request and your own understanding of the world, the policy context. What if your access rights, your usage rights depend on a third party, on your bank account having received, I don't know, 200 euros for that users? How would you make sure in a 3 or 4 party or 5 party transaction, how can you make sure that this is agreed between all the more than 2 participants? And this is actually one of the few genuine applications of a distributed ledger technology. Because there, and I'm not going into details here, there you have the context, the data, and the execution engine. In the project, we have actually done several instantiations of that architecture, because the preceding slide was totally a kind of super high level. If you use BIM data, if you use standards, if you use GIS and weather data, all that, does it work? And the only question which remained open until that is, how would we be able to construct the link model at first? And in our case, we took from the TU Dresden the multi-model manager, which would take some input and would first not only create the model, but also execute and extract the model. And that's it. That's a fully decentralized digital twin architecture, actually not just for the construction industry, for any other industries. The project runs another 11 months. We hope to have all these use cases, 3 or 4, available to demonstrate. If you're interested in more things, the ITCon has accepted that with some revisions. I'm happy to share that with you. Thanks for your patience and good luck with your next digital twin.
Thank you very much, Christoph. We welcome now our second keynote speaker, Jordi Escriu, is a member of the European Commission and of the ACJRC Inspire team, and he will talk about the European policy developments around the Green Deal database, data space.
Good afternoon, everybody. So, I have to take it. Good afternoon, everybody. So, I'm coming from a slightly different domain. So, I'm a geospatial and interoperability expert, and I'm working in the European Commission since 2 years now. And today I will explain the developments that the European Commission is funding and working on in order to develop what we call the common European data spaces, and we'll try to also provide some link to your community and especially to digital twins for the building environment. So first of all, I will start with the policy context, and I promise to be not very much boring on that. So first of all, this is coming from a priority for the current European Commission, which there is this twin green and digital transition, which is at the top of our policy agenda. So Green Deal means protection of the environment, and the second, the digital transition, is more for the digitalization in every domain in order to push a digital economy. First of all, this is somehow channeled through this European strategy for data. And this strategy aims for the creation of a European single market for data. So this is more not so many technical concepts, but it's more economical one. It's focused on pushing for a data economy across the different sectors. So there are some problems to be addressed, which are affecting the current status of the art of data sharing in Europe, which deals from data availability, interoperability, quality of data for artificial intelligence, the governance and the infrastructures that are used to share the data, skills and data literacy, cybersecurity. And at the end, this document, which is the strategy, envisages the establishment of a common European data space and also sectoral data spaces. And I will try to explain it in a different manner. So first of all, this is the image of an Alzheimer-affected brain structure. So what happens here is that the flow of data between the different neurons are not working so well because of several reasons which are more medical ones. But here comparing with the data economy, what happens now is that this is data sharing is sector oriented. There are lack of trust and incentives. Also, the fair practices between the players are not always assured. There is low interoperability of data, limited availability in some cases, or accessibility to the data which is available, and very often unclear or absent licensing. How to correct this situation? So this is the aim of the European strategy for data, and what it envisages is different actions in order to allow the free flow of data between these neurons, let's say, which you can think that each neuron is a different community, which is accustomed to share the data within the community, but not with the rest. And the objective is to share also the data and the outcomes of each of our communities with the rest in order to boost the economy. This should be achieved with trust, providing incentives to data sharing, assuring fair practices, mainly for important gatekeepers that have an important weight in the market, pushing for data sovereignty, pragmatic interoperability, and data availability in general from the different communities, especially with the public sector, with open data, with clear licensing frameworks, and pushing for innovation. And in order to achieve all these objectives from the strategy, there are a wide range of legal acts that would be boring to explain now, but they are each of them focused on correcting each of these topics that I highlighted in the last slide. And at the end, what the European Commission is willing to achieve is something like this, where different ecosystems, data ecosystems, or the so-called common European data spaces are built for these domains, which are just an initial set of domains. And today I am also talking about the Green Deal data space, which is the environmental sector data space, which in fact is also the next step of the INSPIRE directive, the European Special Data Infrastructure for Europe. So how these European data spaces will be somehow pushed or have been are being pushed with some preparatory actions that have been done during the last 2 years. So first of all, we have the experience gained from the INSPIRE directive, which is geospatial data infrastructure for Europe across different member states, covering a wide range of INSPIRE themes, the geospatial data themes, and a long implementation roadmap where at the end we have achieved some objectives, but some of them are not achieved, especially, for example, we obtained the heterogeneity of INSPIRE implementations. Also, the pan-European coverage was not achieved. So, but all the experience implementation the directive have led us good knowledge and experience that could be applied for the next stage of data sharing in European data spaces. And here the GSC provided this Science for Policy report with the public sector contribution of INSPIRE towards the creation of the European Green Deal data space, which is more or less explaining that we should push for a new data ecosystem, more flexible and agile. Also, I will try to provide some reports that we have been working on for the creation of this Green Deal data space. One of these is a policy brief which we prepare for the European Commission DG Environment in order to provide our recommendations, or which are possible legal interventions in order to modify INSPIRE, the revision of INSPIRE towards the creation of this Green Deal data space with a modernized environmental data sharing perspective. And more in general level, for not for the environment, but also for any data spaces, we provided this report with scientific insights into the data sharing and utilization and scale, which is a kind of easy entry point for the implementation of data spaces, with the concept of trying to provide ingredients in order to build them, mapping to the requirements that comes directly from the European strategy for data. As you can see, this report is provided in a graphical way, so it's not intended for technical audiences, but also for general purpose and every domain. How we push for the European data spaces? So first of all, this is done by funding actions. And during the last 2 years, we had these preparatory actions, which were from the transversal level to the sectoral level. So at the transversal level, we had this data spaces supercenter, which are providing horizontal coordination for the creation of the sectoral data spaces, and then for each of the domains, there were some specific coordination and support actions in order to start shaping the creation of each sectoral data space. There is also the European Data Innovation Board, which is supposed to provide consultative and advisory services in doing that. This is the Data Spaces Supercenter information, in case you are interested. This is the great project, which is the coordination and support action for shaping the creation of the Green Deal data space. And I will try to provide a more complex or more information in the second part of the presentation, which are the implementation developments that are currently being addressed. So after these preparatory actions at the horizontal level, the Data Spaces Supercenter and DG Connect is working with this tender that is stated below, the creation of this simple, which is a data space connector. So this is supposed to connect the different elements in the data space, in the global data space, where we are connecting the clouds, for example, the industry clouds, the IoT cloud. Also, a possibility could be to connect to the building digital twins as well. And the vision is to go for a federated data ecosystem where all this data sovereignty, control over the data you are sharing, etc., are considered. And there is no physical data integration, but it's more kind of based on distributed data warehouse created for specific needs. In the meantime, the Data Spaces Supercenter is continuing their work, providing different versions of what they call the assets in order to provide support to the rest of the initiative for developing sector-specific data spaces, including, for example, a list of cross-domain standards that could be useful for the creation of that, and the shaping of what they call building blocks. Building blocks which are of organizational matter or technical matter with different aspects to be considered. So on top of these building blocks that they develop, the standardization bodies like the Open Geospatial Consortium or the ISO TC211 are providing or working a bit more based on the inputs from the Data Spaces Supercenter. And for example, in the case of the OGC, there are a number of, they are participating in a number of European projects which are playing a bit more with these building blocks in order to provide more detail in between. So this is also the call, which is still active. So in case you are interested to participate, the deadline for submissions is at the end of May for the implementation of the Green Deal data space. The first implementation. And the idea is to take the results of the coordination and support action, the GREAT project, which was the preparatory action, and take into account also the related inputs from these Horizon Europe projects, which are related to this project. Also, this call is related to the different use cases that the GREAT project selected as reference use cases. But in the bottom of the screen, you can see more business-oriented use cases that DG environment is taken into account more in the data economy side, which are also related to the ones high-level use cases of the GRID project, but more business-oriented. And as you can see, there are aspects like the digital product passport or the systems for assuring the environmental and sustainability performance of supply chains, maybe digital building permits as well, that are quite related to your community. There are also some studies on pushing for possible interoperability provisions more on the data level for the Green Deal data space that we are being funding as well. Just as a final notes, also a new GRC paper is coming soon about because we noticed that there has been an increasing availability of open source data sources for buildings that you can see here listed. And the objective of this paper is to analyze the differences that you can find if you are taking one of these data sources and comparing with the rest. And finally, this is a new journal. It's a relatively young journal, Data in Brief, where we are collecting until I think it's end of this year. We are looking for contributions on the data spaces, maybe relationship with the digital twins. This could be also interesting in case you are interested to participate or apply or submit an abstract. Thank you very much.
Thank you very much, Jordi. Okay, so now we start with the second session about building a digital twin interoperability. We will have eight presentations now. I have to ask you once more to be strict with the timing because we're a bit late. So with no more delay, we start with Farsad Rahimian and Sergio Rodriguez. Thank you.
Good afternoon. Okay, I just have a background video while I'm talking. It's just pitching the type of the work we're doing. I'm Farzad Rahimian. I'm Professor of Digital Engineering and Manufacturing at Teesside University, Middlesbrough, UK. And my colleague, Sergio Rodriguez, Associate Professor in Digital Construction. I lead a center called Center for Sustainable Engineering, and in the center we have various research groups, including digital construction, which is led by Sergio. We have smart energies, we have circularity and decarbonization, and we have hydrogen research. So basically, what we do is all the areas that I mentioned on demand response in digitalization, virtual reality, etc. But what is about our own research is our unique selling point is digital twin, immersive digital twin for different users. We have projects on various fields from high voltage electrical applications, safety training to infrastructure asset. This is the project that we've been doing in collaboration with one of our partners is Stockholm Bypass, the world's second longest city tunnel, which is halfly done full digital twin, including the surrogate modeling for the traffic data simulation, for the data coming from sensors and all these CCTV cameras, etc. So what basically I also wanted to talk about before I pass to Sergio to explain. Our unique selling point is immersive digital twins. We work on the applications of immersive technologies, extended reality for health and safety training, also the adaptability of technology when we're talking about the user logic versus the design logic, when we have some fancy solutions, but is it going to be bought by the end users who are the workers, the managers on site? These are the things that we focus more. Just a little bit of advert, also publicity. We together run a Smart and Sustainable Built Environment journal published by Emerald. I'm editor-in-chief. The journal at the moment has site score tracker on 9.1, is one of the leading journals in the world, and I'm also associate editor for automation in construction. So I stop my presentation here and pass to Sergio. If we could just swap.
Can you swap to the other video, please? Thank you. Thank you, Professor Rahimian. And yes, one of the main topics that we haven't spoken about is what do we do with what we don't want? Okay, so it's actually related to waste. We speak about digital twins, but what happens with actually waste is what we discard. Okay, so in this scheme, we have started work in actually needing to reduce the waste to the minimum, maximize also the amount of second life materials that we use in construction, and also in the end to reduce the carbon footprint of the materials that we use. In Reconstruct project, we have already approached the problem of cement and concrete. Cement and concrete represent more CO2 emissions than many of the countries in the world, okay, by itself. So it's a major problem, and we need to address it. So in Reconstruct, which is a project with 16 partners throughout Europe and also in the UK, we have already delivered one strategy that accomplishes the concrete life cycle assessment, or the concrete impact on the environment, in a project that will have 2 demo sites, one in Barcelona and the other one in Brussels. They have 2 also clusters. The clusters are needed because actually any intervention that we do in the construction industry needs to have all the intervention of across the supply chain. We need to count on different stakeholders in the supply chain, and that's what we try to do in Reconstruct. So the next thing that we are going to do is to present our role in Reconstruct, which is actually digitalization of the waste management in the project. So first of all, just highlight the significance of this aspect. We don't realize how impactful is waste in the construction industry, but it's actually, for example, in the UK, it represents 62% of the total solid waste in the construction industry by itself. And also, if we talk about millions or actually the netto quantity, it exceeds 3.5 million tons of carbon dioxide in terms of emissions, of global emissions in the UK by the Construction Leadership Council. So that gives you the background, and that gives you the necessity of addressing this type of project. So first thing that we did is actually to consult with industry stakeholders, with construction stakeholders, and we asked them, how can we quantify waste? Because actually, if we, as Lord Kelvin said, if you want to improve it, you need to be able to measure it. So the first thing that we need to do if we want to address the problem of waste is actually to be able to quantify waste reliably. So that's what we did, and so we retrieved from the stakeholders and the literature, we retrieved that actually there are some ICTs that can affect or can improve the construction waste management approaches. There's also circular economy principles that are a methodology nowadays to actually improve the industry cycle in order to reduce the carbon impact or the environmental impact of construction or any activity. We have also reverse supply chain strategies and waste hierarchy life cycle assessment frameworks. And the role of construction waste data is actually to be standardized or to go through or towards standardization, okay, so that we can make a better quantification and a better assessment of the construction waste. What are the options that we have in the industry already? What are the options that we have in order to make construction waste part of the digital twins? We have BIM. BIM is actually quite resourceful in order to achieve the level of decision making throughout the different stages. We are not going to affect really the impact that construction waste has unless we address it from the very beginning, from the design stages of a project. So that's what we are, what the role of BIM we see us in this format or in this area. We have also AI-enabled tools that actually help us quantify and help us predict the amount of waste, but obviously they need to be tailored to the exact type of waste and the exact process of construction that we address. And we have, for example, autonomous robots that can actually take a role in segregation, in construction waste segregation and identification of actually and offering new technologies in order to classify and quantify waste through the construction site. And then we have also the incorporation of GIS. GIS actually gives you an opportunity to quantify waste at an urban level and create what we call building as a material storage, so that we have buildings that are actually a source of materials for urban mining. And that's what we already have seen in the literature and some initiatives. What are the problems that we have identified, the limitations for construction waste management quantification methods that are hindering their scalability? First, there's not a unified construction waste data structure. That's a real problem, because if you don't have a structure of data, you cannot actually scale any solution that you are going to do. There's lack of a standardized construction waste classification approach in the world. You might be using the same materials, but actually it works better at cluster level, at local level. There's no real interoperability, or there are very few projects that have interoperability between BIM and construction waste management, quantification methods, and knowledge bases. And we lack of a complete whole life cycle approach. That's actually on, with the last one, establishing relationship with the project characteristics and construction waste generation levels are inadequate. So they are not, we are not addressing, it's kind of a random or arbitrary, the type of identification. And that's because we, luckily, construction waste is considered a discard material. It's not considered a live material. It's not considered something valuable. And that's the problem that we have detected. So we have created, for the Reconstruct project, we have created a quantification method or framework that is consisting of 4 layers: the data collection layer, data processing layer, data standardization and exchange layer, and BIM-based decision-making layer. They are obviously interconnected in a way that the outcome of each, or the output of each of the layers, is actually going to be the input for the next one. Okay. In the first layer, we have the identification, the collection of data that comes from the building geometric and functional properties. We have the data source that can come from a 360 or scanning or 3D scanning, or the project. If we are starting the project in BIM directly, it needs to be at that level of detail, 200 or 300. Okay, and then we have the construction waste factor. The construction waste factor is actually, we need to go to the repositories, we need to go to different sources in order to get the information that is actually reliable, which is not easy. And we need to look for that information and get the single source of truth that was spoken this day. Actually, and the single source of truth is probably going to be just local single source of truth. It's not going to be applicable to all the provinces or to all the regions. Then in the second stage, which is the data extraction and processing layer, we have the native BIM models that are going to be converted to IFC. And the IFC is not going to be IFC by itself. It's going to be IFC using IFC or web technology, web ontology language. Okay, and that's going to help actually get supported by different sources of information. Okay. Then, in relation to the construction waste factor, we find that that this data is this process is data intensive. So actually, we will be needing help of AI algorithms to incorporate the quantification and classification process and enhance the speed of the process. And each algorithm, and this is important, each algorithm needs to be applied to a specific activity. Okay. Then we have building material data, and in the standardization and exchange layer, we have these 4 categories: GIS images, life cycle assessment impact values, multiple data sources. That seamless requires the data sources to share a similar status. Sorry, I'm just reading this one, but. What I mean is that in the end, this is the important point, that we need to have a semantic structure that actually integrates all these 4 aspects, okay, of the data that we have already standardized. Okay, and finally we have the BIM application. So we have a BIM application, an API in Revit that actually helps the designer actually optimize their design. So what we are doing is actually we create the BIM model at level of detail 300, and with that BIM model we give the designer options in order to lower the carbon emissions, it's a multi-criteria decision system. So actually lower carbon emissions, lower energy consumption, lower waste. We can affect all those if we have a semantic understanding of or relevant understanding of the different aspects and the different materials that are affecting the building. So that the materials are already in the BIM model, and they will actually be part of the optimization method. And so those are the conclusions that we obviously need to not underlook the importance of waste. We need to include waste in a category of the digital twins, okay? And the framework actually divided in these 4 phases with multiple sources of information is going to help this if actually attached to the BIM software as well. Okay, and that's it. So thank you very much.
Thank you very much, Sergio and Prasad. Okay. We now welcome our next speaker, Qian Wang. Is a member of the KTH Royal Institute of Technology. Thank you.
Thank you very much. And first, I would like to thank BDT and Edward to invite us to give a presentation. And also, I would like to use this opportunity to present our project called Hypergrid. Yes, and the project started right after COVID, so we have run 2/3 of the project and come into the last stage of the project for 1 year. And I come from HVAC control and BMS background, so the understanding from me for digital twin might be a little bit different. And we are very much focusing on the energy systems for the buildings. And when it comes to energy system, and we focus on, for example, beyond one single building to the district, it's very important for us to understand what's the purpose of having a digital twin. So digital twin should serve a purpose. And that's the whole motivation of this aspect of the project, how it's linked with digital twinning techniques. And this is not really much into, for example, how to design the district and that aspect, but very much into the control and how to develop control sequences to optimize the operation of the energy complex in a district heating. So in this project, we are very much motivated by integrating different renewables into districts. And we have several hardware development, for example, for the modular heat pumps, modular CHP unit, and also absorption technologies, to how we can really integrate this for flexibility services. Because, for example, in certain countries, in Sweden and in the Netherlands also, we have faced several congestion problems for the grid, so we are not having enough capacities, and we need to somehow use renewables, and that is able to be integrated with the existing thermal networks or grid. In that case, we are very much focusing on the concept of energy sector coupling. This means that how we can utilize different thermal assets as a margin of flexibility space to reduce the congestion of the grid. So that's the reason several, for example, power to heat and storage solutions are presented. So this is a little bit the concept, how we can increase the flexibility by energy sector coupling. Here, if we look at the concept, we need to integrate many different, say, renewable solutions or different assets into the existing energy networks. That means that we do need very high level of controls that can operate such complex in the optimal way. And in that case, digital twinning plays a good role there, because we can start to understand in which conditions you should operate what systems in the best way. So that's how we came into digital twinning techniques and how we can implement it into the control sequences. And this has been the work we've been focusing very much, because in order to develop digital twinning, it's very much needed to understand what are the tools you want to use. And if you have, say, 20 different type of system connected into a network, you need to have a robust co-simulation platform. And then the problem comes, because when you have different hardwares, different manufacturers, all of you have different data models and protocols, and how we can operate the control sequences in a, say, in a loop. So that's how we came into more interest in this digital twinning aspect. For example, how can we understand first the load flexibilities? Because when it comes to load, for the electric load, this has been decades of research and analysis how you can predict the electricity load. But when it comes to thermal load or the hybrid load, things becomes a bit messy, because electricity is very fast. But when it comes to thermal load, you have two factors you really need to take into account. One is the thermal response time, because you have the storage effect from the building itself to the district and the current configurations of the storage solutions. You may have tank or PCM storage or even storage for weeks. So you really need to understand load in a way that is accurate enough, but also flexible enough so you can operate the controls on the right component. In this case, we select one pilot we have in the project in Hypergrid. It's located in Austria, and they have a very nice thermal network already that is local. So it's district heating mostly, not cooling, and it's produced locally using biomass, and it has connected to the grid. And on top of that, there are several on-site renewable solutions already there, for example, PVs and thermal storage. So it's a good opportunity. We can try a little bit our concept. Here you can see this is a PND of the flow chart of the system. And during the project, we are really learning by doing, because when we come into a different stage, we face different challenges, how we can really implement. The first challenge we meet is we have problem to really understand and predict the load flexibilities well. Because, for example, if you want to insert thermal storage and plan it well, you need more sophisticated method, and the current method need to be developed. That's the reason we come to different, say, data analytics skills we want to develop and implement. For example, we have done quite much, say, analysis, different method, which one is more robust and accurate to predict loads, especially its hybrid solutions. And then we end up with a hybrid load method that combines physics and also data analytics. So you are not fully relying on data, but also you need data to really train it and see if this is reliable and accurate enough for your purposes. Then we meet another problem. So, because for most of the residential districts, you have buildings that have been built for 50, 60 years, And it's not realistic and too cost to deploy large numbers of sensors and meters everywhere in the pipeline or in the networks. What we want to do is that we want to minimize the needed data point, but also serve the purpose we want to understand the load enough. We came up with a tricky solution, how we can do the data, install like minimal meters and sensors, and then how we can connect this data into the optimizations. Then we come with another problem because we are working from Sweden and the pilot is in Austria. Then the data connectivity and the database construction becomes a problem. Then we installed, for example, IoT sensors. It gives us real time series data. But when you develop optimization, you want to have some sort of interactions you receive the data, place it somewhere in Sweden, and analyze the performance in Austria. So in the end, we came up with this kind of concept, which is actually working now. So we are sitting in another country and analyze another country's data. And then we combine IoT protocols with a database structure that is there. And also, when it comes to energy data, we need to be quite careful because it may concern some people's consumption behaviors. And also, when you have time series data, usually you have locations and tags for the information. So we need to wipe this out so we don't reveal whose PV is consuming how much. So that was quite a lot of efforts we put on this. And in the end, we could actually do this nice predictions. You can see from the right figure that we reach rather good accuracy, for example, for a school, and in winter and in summer. Then you could see that in summer there are some discrepancies. This is because in summer when district heating are mostly used for domestic hot water, this is linked with user behaviors. So yeah. Then we met another problem. So this is a case-specific solution. When you use machine learning or any kind of data-driven method, it's very important, as some of the presenters said, this need to be scalable. So we want to improve this algorithm and method, how this can be applied on different cases, so people do not need to develop such method in each case. Then we continued on this, and then we tried this in different climate in Norway, in Sweden, and in Italy, and we reached rather good results, so it's possible. So there's a future for this. And also we tried a little bit how this can increase. So what does this mean? This means that flexibilities, and it means business. Because when you increase the flexibility potential, this avoid the congestion risks. And we try to quantify, for example, how much you can save by doing this. Yes, and in the end, we are working more now on the ontology part, because when you have the data, when you have the framework, how you can implement it. Then we came back to the first very question that you need to make the hardware, your framework and your control sequences working in the same room. Then we start to develop this co-simulation framework that is driven by ontologies. And in more particular, we're working with brick schema. And for example, this is a very simple exercise we did in Sweden, even for a test bed that is ventilated by heat recovery, and you could see the relationship and the network could be quite complex. So I still think there quite much work to do to really make this happen, and hopefully we can continue this work and deliver. Thank you.
Thank you very much, Kian. Okay. We welcome now Pedro Meda, who's a professor at the University of Porto and also works at the Instituto para Construção Sustentável. Okay, thank you. Thank you, Pedro.
Yeah. Okay, thank you. So thank you very much, Edward and all, for being here. And now I will talk a bit on how digital building logbooks can become digital twin enablers. And actually, spoiler alert, at the end I will change the title, because I had just a very, very small piece of time to think about this. So now that I did the presentation, I changed a bit the title. So moving forward, what is the digital building logbook? And the first question to take over from where Bruno, when he was presenting the conclusions, mentioned that the logbook should be needed. I've been asking several times to my students when I lecture on digital building logbooks what they are, and this is what I get. And this is what they mention without knowing anything about logbooks. And after seeing this, because they are answering and I'm seeing it in Kahoot, I say, well, they don't need this class. Well, not entirely truth, but there are here some interesting things that we have been seeing during the day and during the projects that we are involved that relate to digital twins, that relate to digital product passports, that relate to all the things, all the aspects on digitalization that we want to have related with the built environment. So, but the EU definition of the digital building logbook is that it is a common repository for all relevant building data. Well, audacious. And it says that it facilitates the information sharing within the construction sector. It is a dynamic tool, okay, that allows a variety of data, information, and documents to be recorded, accessed, enriched, etc. It represents a record of major events and changes over building life cycle. And at this point, just remember that without knowing, I was talking with Andre on this. So events was a very, very good answer. So actually it represents the events that happen during the life cycle of the building. According to the macro vision, and here we enter in the political side, so where Jordi presented previously, there are several data inputs from digital product passports mentioned in the presentation, from permitting outcomes, Judith will talk about this, land registry, financial data, design elements in BIM, a lot of presentations talked about it, and then we have that digital building logbook with data inputs and outputs for different purposes. EU data spaces, levels, asset management, material passport, energy performance, smart readiness indicator, you name it. So I noticed, Christoph, we choose the same icons. So similar approach, that means good taste, and we are not that far on what we are talking about. But let's look into the details. And looking into the details, as it was presented, I'm half industry, half academia, so I mix and blend everything. And on the right side, I have practical things. We implemented the digital building logbook in a municipality, and at that time, that was before all the studies on digital building logbooks, we got that organization, background information, administrative information, the one that is available to all people and the one that needs to be protected with GDPR, construction data use, energy, risk, etc. This was the way we saw it. Of course, the recent studies organize it in a different way, but yeah, no problem. We can set some connections between it. So most important is the functionalities, deliverables, goals of the digital building logbook. So what is the purpose of the European Commission and other countries when trying to implementing the digital building logbook, or say making use of the data? And sorry, terrible drawing, my own, okay, but I write with my left hand, so I would not become an architect. But I think you can get the picture. So the digital building logbook, in our vision, starts when we don't have a building. We have an idea of a building that is going to be built in a place. So we have land parcel, and that is information that is relevant for the logbook. And then we have property tax, building potential, paper in databases, wherever. It should be imported to the digital building logbook when it is deployed. Then we have the building in use, and that land parcel will have different owners if it is a residential building. So I have parcel A, parcel B, property tax, etc. It is part of the digital building logbook. Of course, not all people will have access to this. Gets close to what you mentioned, Christoph. And then at the end of 50 years, 100 years, we are going to have the building at the end of life, so we don't have the building anymore. We get the same land parcel, and we get tons of stuff. So as Sergio from T-Side was talking, we have products that should be, so it is a building that it's now seen as a material bank or material source or waste, wherever. We need to have a bill of materials to streamline the reuse and recycling of those products. Another example, it's energy efficiency. And I cannot recall who talked about energy efficiency, but I have some notes here. Paris, I think Paris Folkheitz was talking about energy efficiency. So we have a sandwich panel that we needed to do the calculation of the energy performance certificate. So we will have a product catalog where we're going to pick up the digital product passport. It will become part of the project product catalog in the DBL. And then during design, we do the evaluations. Then we can redo the evaluation and confront it with the digital twin after construction. And then, so during construction, sorry. And then during use, we have the real energy consumption and etc. Okay, so we can control if the product performance and the building performance is accurate or as it is supposed to be or not. Last example, and this goes to what Lavinia was presenting, is fire risk. So eventually we have a product that is not flammable during the design, so we run a compliance checking and is okay, but then there are changes during the construction, and we change from manufacturer A to manufacturer B. There are new properties, and we should have a warning that a recall is needed because the compliance might not be granted. And I'm not going to enter in details because those that are from Spain and from UK know what I'm talking about very recently. So main assumption is that the digital building logbook starts with parcel data, then to move to urbanization data, initial design data, technical design data, construction data, and eventually it can be prepared for use data. And all with a lock there, meaning that it is secured as it is supposed to be. So we did a business process notation. Actually, it is there. Business process notation for high level 1 for the digital building logbook. And going straight to the operation phase, we have here several, say, levels of information that should be ensured by the digital building logbook. One of them is related with warranties, maintenance, and refurbishment that we can summarize on getting that compilation of life cycles. The construction process life cycle, the built object life cycle, but also the construction products life cycle due to the reuse and recycling that nowadays is key for the Green Deal. We also need to collect events because it is in the description and because we know that these can make a lot of changes on the built environment. So we have 2 examples there of events that can impact on buildings. We also should be able to do recalls, either because there are updates on the regulations or because we do changes on the buildings that require this re-evaluation. And we should do it systematically and effortless. And at the end, we have, I'd say, 2 things. Sensors, so sensors for the building to monitorize its use, and then the relationship between the building and the location where the building is. So a bit like related with the smart cities. So this is to summarize what and for what. And at this point, how familiar does this sound with the things that we have been here listening? And actually, I must say, quite a lot. So I stole, Edward, apologies, but credits granted. I stole the image from the Sphere white paper on digital twin definitions for buildings because it's actually the same or very close. 1 minute, yes. I must say, one thing that is missing is the changes in the title. So from how we change to why digital building logbooks must be digital twin enablers. Thank you.
Thank you very much, Pedro. Okay. So now we welcome Raúl García, who is a professor at the Escuela Técnica Superior de Ingenieros Informáticos at UPM. Thank you.
Good afternoon. I come from Universidad Politécnica de Madrid. We are researching in the Center for Research and Innovation on Artificial Intelligence, and today I'm going to tell you a bit about the initiative with Sareb that we are making in ETSI, okay, one standardization body at European level. Okay, we have been talking a lot about digital twins. Today, one thing that I didn't listen much is about this synchronization between my entity and my virtual representation of the entity, okay? That this synchronization usually requires us to have a set of sensors, actuators, in order for interchanging data with this. We need to have this Internet of Things data in most of our digital twin deployments, and we have to collate all this data, as Pedro mentioned very well right now with the logbook and with anything. We need to collect with all the data that we have from the life cycle, not only of the digital entity, but also of the physical entity, okay? We have this IoT data. With all these interconnections, we have to ensure that we can interoperate inside my digital twin, okay? We need semantic interoperability at this level, and we need also semantic interoperability between my digital twin and other entities, another digital twin, another data space, or any other information system. If we focus on the IoT, okay, we have a very huge fragmentation. This is nothing new. And we need these semantic models, and here you have to make a leap of faith, because today I'm not going to talk about this, but you need semantic models. You need to be able, for your systems, to be able of interchanging, not only interchanging data, but understanding the data that has been interchanged, okay? And for that, you need ontologies, okay? I'm sorry, but another day we can talk about this. But now I'm talking about Sareb, in which we have these goals of being able of having these semantic models in order to represent different things. And we have here different perspectives of interest. I have a set of sensors, and I'm interested in representing them in a uniform way. I have different sensing infrastructures, water, lighting, electricity, and I need to integrate them, again, interoperability. Or I need to enable interoperability between infrastructures from different vendors or from different authorities in a decentralized scenario, like Christoph was mentioning before. Okay? In this context, in the IoT domain, in 2000, well, more than 10 years ago, promoted by the European Commission and by ETSI, appeared the Sareb initiative with the goal of building an ontology that to support building applications that use IoT data, but again, and all the rest of the data that we need in all these scenarios, for example, in digital twins, as we have seen. I will give now summaries, but you can imagine that over time we have been developing this ontology, we have been improving it. In 2000, version 3 was published in 2020, now we are working in version 4. We have been evolving this family of ontologies, and we have been evolving also all the things that support the governance of these ontologies. That is what I'm going to show today. Currently, the Sareb ontology is a core ontology with 12 extensions, okay, that cover things like Sareb for energy for demand response, Sareb for grid for the smart grid, water infrastructures, environment, industry, smart cities. If you think about the use cases that we have seen right now, we are covering a lot of these things, buildings in digital twins. The idea of Saref is to have this umbrella, no, that allows me to interoperate in these highly cross-sectorial environments in which we need to interchange IoT data. And here we have in digital twins the perfect example for this. Okay? This is the best slide of today, okay? making this work over time, no? So here, and the main part, this is something that in European projects, we have some lightweight approach for this. But so here we needed a really good governance approach for our data models, okay? What is this composed of? Of a set of principles. Not anything can be into a Saref ontology. We have guidelines for users, a set of requirements, and the nice thing is that these requirements can be automatically verifiable, okay, in order to say when you are doing something in the correct or incorrect way, no? For checking for compliance. We have a set of processes, we have actors, an ontology development methodology, we use the lot methodology, a set of workflows, so in every moment, anyone making a change request over the Saref ontologies can know in which state the request is made and if it will come to a success or not. All the principles, processes, and we also have requirements over the technology. We have a technical development framework, and we impose some requirements on how this has to work. Okay? All of this is paper, of course, and we have different technical specifications that define this. And of course, we support this with technology, following these requirements. We have an ontology portal where everyone can go there and check the latest status of the ontologies and all the previous versions. Okay? We have a version control system where you can submit change requests, defects, whatever you can find. And we have the Saref pipeline that checks the correctness, the compliance of the ontologies. This is automatically run with GitHub Actions. The compliance of before every release or whenever we want, of the ontologies according to these requirements, okay? And this makes use of other tools. So we ensure through previous verification and posterior validation of the artifacts that we have everything correct. One thing that we are working on right now, and we have a first draft already, is an EN, a standard at European level, on the set of guidelines on how can you use Saref for implementing semantic interoperability, okay, in your use cases. Okay. Right now we have a first draft, we are distributing it, it will go to the national bodies and so on, in order to raise this from an ETSI standard to a European standard. And this way the goal is to have these guidelines as a set of support for people, not only for people using ontologies and so on, but also from policymakers, regulators, to say, okay, I have here a set of, again, minimal requirements that you should satisfy, for example, if you want to provide me with some ontology for IoT. Okay, this is very interesting. And that's it. And finally, what we have been seeing the whole day, what do we want to see? We want to have fully semantic interoperability in digital twins. No? We want to see not the physical object, the digital object as a global database, okay? Where we can say, I want to ask things, okay? Here in the presentation of the Cogito project, you had an example, no? I need to perform a work order with some worker in some context, and I want just to ask, okay? With a query language if I'm a software developer, speaking if I'm a person, but I want to ask my digital representation and get an answer. I don't want to be collecting data, putting things together and things like that. And that's it. Thank you very much for it.
Thank you very much, Raul. Okay, now we welcome Judith Fauth. It's Maria Sklodowska postdoc at the University of Cambridge. Thank you.
Yeah, good evening, everyone. Hello. I promise I will keep in time. So I have the great pleasure to present my quite new project. I'm just started 3 months ago, so I do not have any results yet. Rather than I want to show you the concept I am aiming at. And thank you so much for the invitation, Edward, for being here and present that to you. So it's about the integration of road digital twins for streamlining planning and building permitting. Let me explain that. So I start with my research focus, which is actually always about planning and building permitting. And from there, I'm going in different directions, digitalization, ontologies, but also a lot of process analysis and all that. And now, I'm at the University of Cambridge, affiliated to the Digital Road of the Future initiative. You probably all know Yannis Prilakis, who is my supervisor, and I think he presented this initiative 2 years ago at the same conference. And you may wonder, what is this actually about, connecting roads and building permits, planning and building permits. There was a challenge advertised at the initiative. So how can road digital twins generate value from connecting areas? And I do not read through the questions now, but you can guess my connected area are the planning and building permits. So the idea behind is quite simple, I would say. So we have roads and we have road digital twins, or we assume that at least. And we have cities and buildings where we need permits for. And but the roads and the road digital twins may have information already stored, which we can use for planning and building permitting and vice versa. So the idea of the project is linking road digital twins and building permits. So I think that's obvious. We want to reuse the information and breaking down the information silos that may exist, and also leverage the connection to generate value for both. So now I'm just showing quite quickly my project idea, so which is all based on information packages. I will go to that into a little more detail, but also about knowledge management. Uncertainty is a hot topic here, I would say, and the business case development. So the first work package is about the information packages, so which means which information really are met between roads and planning and building permits. So, but it's not just about what information, but also about when do I need that information and who is the stakeholder involved in that process or action. You probably wonder what could the information packages look like. I do not read through them as well. But just maybe 2 examples, like the accessibility of the plot of land and utility provision. So probably it depends on the water pipes, what dimension they have, and does it fit the purpose of the project to be built. Also, another example, what I call dynamic regulations, the 6th here. It's about, imagine you have parking spaces, which is regulated in the building code, saying, for example, that a building has to have 1 parking space per housing unit, just an example. And of course, those parking spaces are related to the road, so the digital twin would have that information already stored. And what I mean with dynamic is thinking of a development area. So maybe you have already covered or like saturated the area with parking spaces because you have built a car park or whatever. Why would you need to deliver for the building to be built the same amount of parking spaces when we think of like a bigger area? So would we be able to be more flexible with that? And this is not just about parking spaces. It could also be for example, charging stations for electric vehicles, either bicycles or cars. because this also affects the grid. So if we have even too many charging stations used in the same time, which might cause us other problems we are not aware of yet. So yeah, then it probably goes to knowledge management, maybe through an ontology, let's see, so that we also can have some queries. So give me that specific information, maybe for the application, for a building permit. Then the uncertainty, it's a very nice topic, I would say, and there's a lot of uncertainty in planning and building permitted in different kinds of levels and so on. So I won't go into detail here, but maybe we will also be able to, let's say, to objectify some decisions which are made so far. So the target, more or less, is a decision model that which features a resilient but also flexible and scalable model, even accommodate the unknown case and be cross-border, like unknown, like the charging station example I just explained. And then coming to the business model, which is for me quite far in future, but how could that look like? And I just show you very simple calculations. So we have 300,000 building permits per year in England. Even if you just charge like £10 for a bit of information, which we have to collect manually instead if we wouldn't have a digital twin, so we could generate some money to maintain the roads or the road digital twins. So my next steps, and this is really my last slide. I'm going to have some workshops, so one is already done, and to collect or to discuss requirements from regulation and the design. I have to do it for the building part and the planning part. It's separated. And I will also do some interviews to also investigate the institutional requirements, meaning from the municipalities and other stakeholders involved in the process. And so which information flow? Does the information flows from the road to the building or vice versa, like from the building to the road? And how do they match? And I have to consider different kinds of layers, like the regulation, information, process, but also stakeholder. And these are all the industry partners involved. I have to acknowledge them. And thank you very much.
Thank you very much, Yuri. Okay. Our next speaker is Suna Wang. She's a PhD researcher at TU Delft. Thank you.
Thank you very much. Today I'll be presenting some key learnings from our demo blog project, as well as my PhD research on digital building logbooks, DBLs, but in the context of energy renovations, and more specifically on the importance of creating interoperable digital data sources for the DBL to produce and generate accurate renovation advice. When we talk about energy renovation in the context of homes, homeowners are often faced with several challenges and barriers, among which I'd like to stress on two macro groups, the socio-technical and the financial barriers. On the former, it was identified that sustainable technologies are often misaligned with the capabilities and the needs of the end users. Two main causes I'd like to highlight here is the clear lack of information and support provided to the end user before, during, and after the renovation works, as well as the undefined process to designate responsible stakeholders to identify, plan, and deliver these works. On financial barriers, a recurring challenge is to provide homeowners with the viable and compelling business case to invest in energy renovations. Contributing reasons include the lack of funding schemes and opportunities, and also the information about them, as well as limited to no provision of a clear overview of the profitability of the energy renovation. But what if homeowners can easily track the changing statuses of their homes through the comforts of their screens? And what if the same platform can also provide insights on the energy performance of the home, identify priority renovation activities with an overview of the costs, and inform homeowners of their renovation obligations to ensure that their homes meet the minimum standards over the years? What you saw on the screen is the Woningpas, which is an example of a DBL that's active in the Flemish region of Belgium. As was earlier established, the DBL is defined as a common repository for all data and information relevant to a single building. Why? To address issues such as data loss and data unavailability that's caused by the inconsistent way of data collection that's practiced by the various stakeholders across the AECO sectors. A DBL therefore records and traces every change made to a building across its life cycle, including but not limited to changes in ownership, tenure or use, maintenance, and refurbishments. But as we've seen from the Woningpas example, the DBL has evolved from the mere common data repository to a digital processor of building data, providing extensive information and analysis on the homes. Now, ideally, the DBL can also be seen as a simple user-centric solution that enables all homeowners to easily identify renovation needs of their homes and address them accordingly. How this works is that once all the necessary data is stored or linked to the DBL, the services built around the DBL will then process the data to provide useful and relevant information that is needed to, for instance, design renovation roadmaps, plan the costs and finances for the renovation activities, as well as monitor and assess the decarbonization progress of their home. And these services are what we call functionalities. From studying 31 existing DBL initiatives at the exploratory stage, we were able to identify 21 common functionalities. And these functionalities can be further categorized to serve 4 main purposes, which are information storage, quality and performance monitoring, building assessments and calculations, as well as integration with external sources and tools. So, what kind of data do we need to store in the DBL to generate more accurate energy renovation advice for a home? For that, I would like to direct your attention to this little part. As a starting point, the renovation wave identifies the EPCs, the building renovation passports, smart readiness indicators, and levels as priority building information. The EPCs are intended to provide tenants and buyers with reliable information on the energy performance of the home. And to generate an EPC, lots and lots of data is needed, including those from documents such as technical plans, HVAC guides, survey reports, and in certain cases, data from other digital tools such as BIM and GIS, as well as digital twins in the future. The Building Renovation Passport, or the BRP, on the other hand, is essentially an evolution of the EPC. Essentially, it's a user-friendly document that outlines the long-term, step-by-step renovation roadmap for a building to assist homeowners when planning staged deep renovations. When stored in the DBL, the type of information that can evolve over time can range from the available financing options for renovation projects, such as green loans and government incentives, to energy bills, smart meter data, equipment maintenance requirements, as well as insurance, property plans, and obligations. The added data of the smart readiness indicators, or the SRIs, which assess how smart a building is in terms of responding to the needs of the occupants, and Levels, which is a European framework for core sustainability indicators that assess and report on the performance of the building, will not only ensure that quality data is provided to the DBL, but they can also support the EPC and BRP data to provide even more informed advice on sustainable and smart building renovations. In practice, however, it's observed that what constitute as priority documents really depend very much on the context and goals on which a DBL is developed. Going back to our example here, the Woning Pass is a public initiative that's owned and developed by 3 agencies of the Flemish government as part of the implementation trajectory of the renovation wave and the regional decree on building passports. Linking the Woning Pass to all available government data is thus central, which is done so with APIs. And this way, the Woning Pass is not only automatically fed with an abundance of data, which is verified, but it's also why the DBL can also be made freely available to the homeowners of all 4 million individual housings in Flanders. As such, information categories currently offered by Woning Pass that make use of available government data include cadastral information such as soil characterization, water and sewage, and flood sensitivity, as well as certificates such as the EPC and the Flemish EPB, building permits and mobility assessments. And with the added data and information manually stored in the DBL and data from other monitoring services such as meter data and potentially digital twins, the Woning Pass can provide accurate analyses of the quality of the homes as well as the energy performance of it, and then subsequently suggest accurate overview of the priority renovation activities. So what does this mean for us? It can be observed that the interoperability of a DBL to its data sources highly depends on what constitutes as priority documents for the individual DBLs. But regardless, for a DBL to generate more accurate and effective strategies for a high-impact energy renovation, a wider spectrum of functionalities is needed. A wider spectrum of functionalities means a wider range of data fields, and a wider range of data fields means a wider range of data sources. Now, the digitization of the AECO sectors will lead to the collection of larger amounts of heterogeneous data through innovations such as the AI, real-time monitoring, and as we've been discussing today, the DTs. And increasing the interoperability between these available digital data sources is therefore essential in the context of energy renovations and the DBL. Yes, thank you.
Thank you very much, Suna. Okay, now we welcome Eloy Coloma, Director of Coloma and Armengol and PhD lecturer at UPC. Thank you.
I think it's your turn right now, no? Oh, no worry. This is mine? Yes? Perfect. Yeah, sure. Okay, thank you. Thank you, everybody, for being here. Today we have seen several digital twin solutions or even DBL solutions, but all of them has the same challenge. That is that they must have the same lifespan than the physical assets that they represent. And this is a big challenge because we are talking about decades or even centuries of years. And for us, it's a new challenge as a civilization because we didn't do it, but it's true that we have some experience developing informatic systems that has been a life of even 50 50 years. So I'm going to talk about some strategies that we know that are correct or are useful in order to try to reach this challenge. Okay, what are the challenges of long-term digital twins? One of them is to avoid to use closed data formats because, as you know, if we use closed data formats, all the information is not going to be accessible for all the people during a lot of years. Of course, the other challenge is the dependence, in some cases, of proprietary protocols that are closed or that are black boxed. So they are accessibility, they have some accessibility about APIs, but not completely open. And another is the short life cycle in comparison to the physical assets of the software solution, generally speaking. Okay, we don't think or we don't count. Our expectation is that, for example, maybe Microsoft is going to be alive during another century. Okay, it's an incognita. So let's see what could be the solutions to that. There are some evidence. No? First one is to use open data formats for obvious reasons, because all the information is well documented that it can be accessible for everybody during time, or at least it has worked until now. The other is to use open protocols. This is harder, okay, because we need to standardize all the protocols that we are using in different scenarios, for example, Internet of Things and these kind of things. And the other one that maybe is the most polemic or challenging is the use of open software, okay? Because we need to maintain a software during a lot of time and to assure that that software is going to be alive years and years and years. In fact, all the digital twin platforms that we can see today uses some of that strategies, okay, by some way. But let me try to explain what consists, because more or less can be evident, but there are some points that could be interesting for us. One of them is the most evident thing is to use open data formats. It's not only about interoperability, it's also about being the ability of recover a data format, a document that was written 20 years ago with a new software, okay? This is very important, for example, for the DBLs, okay? The another thing about data formats is that when we use an open standard data formats, we are by some way forced to make a transmission of knowledge that only contains what is strictly needed. So we have the opportunity to remap the proprietary data formats, the niche data formats, to a standard one. So the information gains some quality when I think that when gains some quality when do that. The another thing, so the first step will be to convert this kind, or to use directly this kind of documents and to put in the platform using only open data formats in order to have the accessibility to the building, to the digital twin of the building, and for allowing to the users to access to that information along the years. The another thing, the another challenge is to use open protocols. There are more and more and more protocols and software related with Internet of Things, as you know. Some of them are opened by most of them, I think, that are so close, okay? So we need to address that, because if not, there will be protocols that will be obsolete or directly deprecated. So we need to change that scenario when we connect with a proprietary IP to our proprietary systems, for example, from Siemens, in order to use only open protocols and use only Internet of Things devices that use that protocols. The other thing, the last challenge is to use open software. As you know, open software is very popular, In fact, all of us are using that by some way, okay? And it bases the strategy on that the source code and other rights can be used by any user by some way, okay? It has the longest history, and we have a lot of samples about that. Let's see one sample about this behavior that we can call about, we can talk about the StarOffice history that began more or less in the 1992, but in the 1910, the company that maintains that open software that was StarOffice was bought by Oracle. And at that moment, the people, the developers, most of the developers that was maintaining the software decided to create a new branch called LibreOffice in order to assure that Oracle, that has another roadmap about that software, don't close that software or don't let that to die. The proof is that today LibreOffice continues to be updated, is on the road, and OpenOffice and the other version has stuck it in the past. So we need to assure the same strategy, I think, for our digital tools and our digital twins platforms. And it can be a challenge, okay? And of course, it's another business model. For example, I'm talking about, instead of using proprietary software from Autodesk, it's only a sample, don't get offended, please, okay? It's not the problem here. It's to use other platforms, for example, like Big Rocket or whatever you want, okay? The difference is that in any time, the community or another community can take the code and use them in order to keep alive the surveillance about that, no? It's the same that happens with the scientific knowledge, okay? It's open, and this is our strategy in order to keep our knowledge about the things, okay? So the archetypical digital twins architecture will be something like that, using open data formats, open platforms, and open protocols. What will be the strategy to use that? And when in that point, there is another interesting thing that for me is relevant, that when we use open software is when we guarantee most that we are going to use real open standards, because it's not the same. When a proprietary developer uses an open format, it can add on it special features that can be open, but with a particular aim to their own interest. When that same open format is used by an open source community, the main regulations about that, their own philosophy about that, avoids to implement specific things that are not exactly standard, okay? So for me, using open source software is the best way to maintain an open format or open standards in some way. What could be the benefits? For example, the cost reduction, because we are contributing all together to the development, okay? Improved efficiency, okay? Because everything is going to be more optimized through a very big community, collaboration all the partners, stakeholders from different sectors. For example, the security here is very important in order to avoid breaches in the security. The most security platforms are open source, and the improved reliability for the more or less the same reason. And of course, we have several proofs about that. For example, we have the web and the banking systems. All of them are based on open source. The aerospatial systems and the railway systems, okay? All of them commonly use this kind of strategies in order to assure the survival of these systems. And that's all. Thank you very much, and let's go towards an era of open digital twins. Thank you.
you very much. Okay, so now we give the floor to our last speaker, Bram Baswim, who is the head of fields at Semtech. Thank you.
Thank you. Thanks very much. So it's been a long day, and I'll try, like everyone else, to keep it short. If I don't, raise your hand and I'll stop talking. So I'll report back on what we did this morning at the interoperability workshop. And for those not, or the ontologies workshop actually, as it's named. So for the things that we've seen today, right? Information in digital twins, information exchange between organizations, between applications. We need some mutual understanding. And this mutual understanding enables the interoperability between the applications. And to this for this purpose, in many projects, people have been working on ontologies. Ontologies for digital twins, or ontologies for components of digital twins, or ontologies for permits. And all of these ontologies are, well, they're sort of separate initiatives. And today we looked at like how could we improve the actual interoperability of these ontologies. So maybe one day, God forbid, but we could even stop building ontologies, or at least lower efforts. So a little quiz, what do these constructions have in common? Well, they're pretty and they're old with something new on top, but they're also all things that have been repurposed. So there was an old building somewhere, or there was an old metro line in New York, and it's no longer in use for what it used to be, but people took what was good and they extended it with something else to make it better for their purpose. Well, maybe we should do the same thing with ontologies. And I recently joined as an active member BDTA, and I took a look at the vision and the mission and the open technology framework, and the bold things I underlined they all say the right things, right? Coordination, efficient, open technology, interoperable, and we consider existing domain independent open standards. So the right words are there. And we're on the right track. We have been for the past few years. But we're not there yet. There's still work to do. So we don't have to stop working on our ontologies. So what have we seen so far in 3 small steps? 1, ontologies have been proven to be a corner piece for effective digital twins. 2, by far most ontologies rightfully apply W3C standards for open data. However, the reuse is still suboptimal. There are many different ontologies. People aren't able to find the right ones, or they only find out once they start talking to someone and they're already working on developing their own and they already have their mindset on some solution. So this is what we brainstormed about today, about improving. And we need to be somewhere between the scenario where there's 14 standards and you don't think it's the right standard, and you make the 15th standard. You keep doing this till there's 1 million standards. That's probably too extreme of a situation to end up with. On the other hand, some other efforts we've seen, and this is actually one that we did within BDTA, some other efforts we've seen, they try to make one standard that rules them all. This also, well, it showed us that it doesn't work. So these are different ontologies, and they were mapped in an effort by our members, by our people, by our projects. And the mapping is right for some purpose, but then the next person comes along and it doesn't work for them. It doesn't fit their use case, it doesn't fit their needs, it just doesn't work, or they have a different opinion for some reason. And you end up with something else again. So we have 1 million of ontology mappings, and this is exactly what we try to optimize today. So we've seen 7 presentations in the morning. I will summarize my personal notes on them, like the key takeaway that I found interesting in each presentation. We saw that in Cogito, they used the graphical notation and it really helped communication early on. However, this didn't really ensure that the communication happened early on. So there was a mechanism, but there wasn't the conversation yet. BIM to Twin, use case-based approach. Really good, right? So think about what you need or what someone needs before you start building something. And modeling choices of others were a challenge for alignment. So people found out that there was something good, but they couldn't reuse it because it didn't fit their needs. HiStore. There was a limited number of existing ontologies for their purpose. So that was a challenge, but it was also easy because it meant there was sort of a greenfield where HiStore could just model what they needed and what they thought was right. Easy. Judith, I couldn't name project because there were several projects, and Judith showed us that she said, I'm not technical, so I can't give a technical presentation. And it was perfect because there's a non-technical expert, a domain expert, who knows something about the things we're modeling in ontology. So there's a real need for what she needed. And she was able to vocalize that really well. Yeah, so that was a good insight. Accord and check, it had an ad hoc, or they learned that an ad hoc process kicks issues down the road. So it's not your issue, but someone else has to deal with the issues that you leave open for them. And they also learned that RDF is a key component, however, not a one-size-fits-all. So it's not, for instance, it doesn't work for storing information or for time series data. That might not be the best, even though it is going to play a role somewhere. Digichecks use the modularized abstraction levels in the ontology or the set of ontologies that they developed. So it allowed them to reuse something abstract, but define their own specific things below that. And it worked really well for them. And I wrote something on define selection criteria for, but I don't know for what. I think for the ontologies to reuse. So what they did was they defined 4 or 5 criteria and they ranked a bunch of ontologies against it and decided whether it was one they could use or not. Last but not least, Simne, they use RDF for information exchange and not for storage, so just for exchange. That was their key takeaway. So interesting stuff, right? Like I said, some steps were made the past few years. We held a discussion on this, and from the discussion, we formed the roadmap. And the roadmap, before we go to the roadmap, these are some of the activities that BDTA has coordinated the past few years. So the first 2 are done. The second is ongoing, the abstract ontology that's becoming a European standard. But the third, fourth, or the fourth, fifth, sixth are still things that we could work on. And if we plot these out in time, we see that BDTA was or is an initiator, and BDTA could play more and more a role of a facilitator in the future. So what does this mean? Well, it means that BDTA isn't just a platform where we discuss and where we align together as experts in research projects, but it also means that when someone wants to use an ontology for a digital twin, they will go to BDTA and see whether there is one. So they will search a catalog for ontologies or for a toolkit that helps them to implement these ontologies. So what we need in the upcoming years, not we BDTA, but each and every member, we all need this to be more interoperable, is to have a catalog that provides building digital twin ontologies for all, especially for those who are not ontologists, but just software developers or users, or I don't know, whoever thinks they need these ontologies. And we provide them with instructions on how to reuse, how to build forth, and what next steps to take. So when we achieve this in the future by incorporating these thoughts into our future project proposals and into our BDTA IPs, internal projects, I believe we will really end up with a situation where BDTA is a facilitator that actually helps people become interoperable, and ontologies are just an instrument in that, just one of the instruments. And I think this was the last slide, but I don't know. Yeah, it was.
Thank you very much, Bram. Okay, so that was all for session 2. We ran out of time, so we won't have the round table. So I will directly give the floor to Peter Imbrecht, who will give the conclusions for the workshop.
So, hello. We heard a lot of interesting talks and a lot of interesting technologies and developments and research that's being done. So I'm very keen of seeing that research and those results being applied in the industry. And I think the last presentation was really good, final presentation to see how we can combine the strengths of all your research and all your bright brains to make it happen, that we can apply it in the industry. Because if we don't work together, it will take many, many years. And I think we need, we all want, before we retire, to see a big jump in the digitalization of digital twins and the construction industry, the ICO industry. Maybe also finally some practical things. You have the white lanyard that needs to be returned as much as possible, because for tomorrow it's also being reused, so that's also good. There's a box on the white fence where you can put the lanyard when you leave. And maybe also finally, we need to thank a lot of people. Maybe everybody can stand up because we already sitting a very long time, so that we can give a big applause for some people. First of all, yourself. Secondly, for all the speakers, all the contributors, the sponsors, and definitely as well for the organizers. So Edward, Elke, Sonja, Ignacy, yeah, a special thanks to you because you all made it happen. A lot of energy has gone into it. And hopefully we see you again next year in Kaunas, in Lithuania. So yeah, let's go for a hard applause.